The ideas expressed in the following presentations are those of the speakers and do not necessarily reflect the views of ACI or its committees. ACI web sessions are recorded at ACI conventions or other concrete industry events and will be made available for viewing free of charge for 1 week. Thereafter, they will be archived on the ACI website or added to ACI's online CEU program, depending on their content. You can earn continuing education credits through ACI's online CEU program. Visit www.concrete.org to register. ACI conventions provide an opportunity for networking and for keeping up to date with the latest in concrete technology and practices.
Our second speaker for today is Julian Kang, Associate Professor at Texas A&M University. His topic will be BIM Robotic Total Station, Field Test for Cast-in-Place Concrete Construction. About the speaker, Dr. Julian Kang is the Cecil Windsor Professor of Construction Science at Texas A&M University and Director of BIM Texas Alliance. He's also a member of ACI BIM Committee, where he leads the effort to produce videos promoting the use of BIM for cast-in-place concrete construction. Dr. Kang's primary research includes BIM, construction simulation, RFID in construction. He is interested in investigating how these emerging technologies would welcome facility to improve productivity in construction. I would like to welcome Julian Kang to the I'll just load you.
All right. Thank you for the good instruction. I'm Julian Kang from Texas A&M University. You are supposed to say howdy to say hello to you guys this morning, because that's the way we say good morning and down in Texas. Today I'm going to talk to you guys about some challenges that you guys may have when you plan to use the building information modeling, especially for cast-in-place concrete construction, especially for the quality control. Our belief is that you are going to build a building exactly identical to your building information model in the 3D space. But in reality, as you may know, things going on the job site might be a bit different than what you have in the building information model. And then whenever you try to use a prefabrication or a modularization methodology, you will get some challenges because of those, some challenges or some differences between what is going on the job site and what you have in the building information model. So that's what I'm going to give you a presentation today. All right, let's start talking from productivity. I guess this is a kind of a famous chart that you may all know already, familiar with. And the productivity on with the non-farm productivity, non-farm industry, including automobile industry, their productivity has been increasing for the last 50 years, since 1964, almost by double, more than double. While the construction industry, their productivity has been declining for the last 50 years. And we've been talking about this, production decrease for in many channels. And then many of us believe that the building information model could be one of the tools that we want to use to increase our productivity back to, like, the one going with other construction industry, other industries. And then many people believe that building information modeling can help us detect more clashes effectively, especially before you hit the construction. And then it's also helping you coordinate special issues with your subs. And then also it will help you get your clients more actively engaged in the pre-construction planning. And also it's going to help you do more prefabrication and modularization technique. And then it's going to speed up to the quantity takeoff process and the cost estimation process. And most importantly, we believe that it's going to help you visualize the construction sequence so that you can see how the building is going to get built, and then you will have a chance to talk about your constructability issues and things like that, so that it's almost like you run the project, you run the construction project in advance before you hit the construction job site. It's very similar to this. I bet many of you guys been assembling the furniture, for which you are supposed to assemble those furnitures by yourself. When you assemble those furniture for the first time, how many times that you make mistake, from reading the instructions and things like that? You spend quite a lot of time to understand what's in the instruction, and I bet you've been making some mistake because you misunderstood what's in the instruction. But if I ask you to assemble the same furniture once again, I bet you don't even have to read instruction at all, because you remember all the processes that you took, to assemble the furniture right before. Construction is about the same. If you have a chance to run the construction processes from the beginning to the end in the virtual world, then you will have a chance to make some mistake, and you will have a chance to come up with some solution for those mistakes. So you can change the construction processes, and then when you hit the job site for the real process, you're not going to have the same mistake again, and then all the process is going to be implemented as seamlessly as you can. That's what we want to have in the construction industry using the building information modeling. And then for prefabrication and modularization methodologies, according to the Green BIM Smart Market Report issued by McGraw-Hill in 2010, 77% of interviewees believe that building information model allow them to use prefabrication technology on the larger and more complex projects in the future. Understanding that more people are talking about the prefabrication and modularization, McGraw-Hill produced the Smart Market Report again, this time on the prefabrication and modularization 2011. And according to this report, 66% of those who reported, or those who interviewed, who got interviewed by McGraw-Hill, reported that they were able to speed up the project. And some of them said they were able to speed up their processes for more than 4 weeks. 65% of them told that they were able to save construction costs. And some of them say that they were able to save more than 6% of the construction cost using a prefabrication and modularization. And then 77% of them reported that the construction site waste has been reduced. And this is a great outcome. People enjoyed using the prefabrication and modularization. And this prefabrication and the modularization is not new. As you may know, in 1968, we had a very interesting project went on in Texas using prefabrication and modularization. It is the building construction project of Hilton Hotel down in San Antonio. What happened was in 1968 there was World Expo, World Fair was held in Texas, in San Antonio, and then I believe because of many reasons, the entire construction project was delayed. And then Zachary Construction was supposed to build this hotel in a very short amount of time. And then knowing the time constraint, Zachary Construction made the decision to go with the prefabrication and modularization technology. And then what they have done was they prefabricated the module of a room which is decorated beds, carpeting, and TV, and even coffee machine all together. And then they got those modules lifted and then stack them on top of each other. From doing that, they were able to, stacking up 496 modules in just 46 days. From the 5th floor to 20th floor. They were using cranes, and sometimes they were using choppers to get those modules stacking up on top of each other. And amazingly, they were able to finish stacking up these 496 modules in just 46 days. And using the prefabrication and modularization technology, they were able to finish the entire construction projects from designing through construction to opening the hotel for the customers just in 202 working days, which is an amazing result. Now, in 2011, there was another case where people were using prefabrication technology, and this time it happened in China. In Hunan, China, they built, there's one construction company, I believe, a broad sustainable building, built 30-story buildings in just 15 days using prefabrication and modularization. And they uploaded the YouTube video on the YouTube, so you can watch their videos and then kind of see how they were able to put 30-story building in 15 days. And this is just a snapshot of their video. And what they did was they prefabricated the section of the floors in a factory, in a controlled factory, and brought those floors to the job site, get them lifted to the floor using the crane. And then they were able to stacking up these prefabricated floors just in 360 hours. They worked 24 hours to meet the 15 days for the completion, and then it's amazing project. And let's see if the video can be working or not. Okay, obviously it is not working, so let's skip the video. If you go to Google, just hit 30-story building, 15 days, then you should be able to find out this video clip, and then you can be amazed as I did. All right, now let's talk about the our processes, our project, which is about cast-in-place concrete. The two cases that I gave you was basically they used the concrete, but they fabricated everything in the factory, and then we don't have to handle this situation on the job site at all. But in many cases, when you are using cast-in-place concrete construction, this is what you have on the job site, right? Now, with this situation, can you possibly utilize the prefabrication or modularization technologies? And then, believe it or not, some companies even tried to use the prefabrication or modularization technologies with this cast-in-place concrete. What they did was they prefabricated some metal attachments and brought those metal attachments to the job site and then get them attached to the concrete embeds. And then they can speed up the process of putting the cotton wall of the buildings, things like that. Now the challenge that we have in terms of using this prefabrication technology for cast-in-place concrete is the difference between what we have in the building information model and then what you will have on the job site. And then this is the embeds where the metal attachment is going to get attached to. And then if everything is going okay, this is what you're going to have, right? You have the concrete beam on top, and then embeds is kind of insulated attached to the reinforcement bar. And then at the bottom, you will see prefabricated metal components being attached to these metal embedments. Right? This is this is real situation. What's going to happen in real situation is, by the way, this. All right, the forms are getting relocated in the process of putting the fresh concrete, and then the the location of embed is also going to get relocated as well, because the forms are getting kind of getting twisted. So if you want to put the same prefabricated metal components to this wiggled concrete beam, you will end up adding more metals to the lag, or you may have to cut the lag to some extent to get this one matched perfectly to the concrete wall. Obviously, this is going to ask you to do more work on the job site, and at the end of the day, you might be thinking, why do we go with the prefabrication if we have to work on the job site anyway? Right? So the question is, can we inform ourselves of this situation as quickly as possible, probably through the building information model, so that they will get the updated building information model, and then they prefabricate their metal attachment using updated building information model. So the question is, how can we collect the data of the existing status on the job site quickly and then bring them back to ourselves? And then normally on the job site, to see how well you guys did, you were using this tape measure to get the dimension of the structures, things like that. I don't believe any of you guys believe that this is something that you want to use to bring those status back to yourselves. What you may want to use is something like this. What you're looking at is a robotic total station, which is using laser scanner to collect data points or to help you identify the point data on the job site. And then this thing is automatically targeting the future using the laser scanner, and then also it can get some information from the building information model for the location of the points, and then also it can check the robotic total station can be utilized to check elevations, locate columns, walls, and things like that. So it's kind of a pretty good tool, that we could utilize to get the status from the job site and then bring them back to ourselves. And then reflector this distance measuring option is something that you guys may want to pay attention to, because it's going to help you collect the point data from the job site even from a distance. And then wondering how far we could go with this robotic total station on the job site, we teamed up, research team at Texas A&M University teamed up with Skanska USA building to test 2 major robotic total station technology, and then see how fast they could collect the point data from the job site and bring them back to ourselves, so that subs can enjoy prefabrication methodology for the projects. And then we wanted to we wanted to increase our knowledge about the robotic total station from the construction manager's point of view. And then we invited 2 main technology vendors, and then we used those technologies for ongoing project at Texas A&M University. And then what we asked those 2 vendors to do is to collect the data from the BIM face, and then silt embed location, and then column location. So we asked them, hey, find out the location of these objects as quickly as possible. So what they did was they kind of brought their machine and then actually implemented the task. And then as you see here, both of them were able to set up the system in about 10 minutes, and then they will collect points from the beam surface within 5 minutes. And then on for the embed, they were able to detect more than 1 embed in 1 minute. But for the columns, I saw them spending more time, because they had hard time to find out the line of sight between the mother station and the column. So they ended up spending over 20 minutes to locate 1 column. But overall, their result was amazing. And then the next question we had was, now we collected data points from the job site. How can we bring those data back to the building information model, for which we have developed a small plug-in application, which is collecting the data and then bring the data back to the Revit in this case. So this application takes the data from the text file and then bring it to the Revit, And then, combining these points with this existing model, you can get something like this. So you can visually check, how accurately you built your building on the job site. And then with this information, you can inform your subs what they are supposed to do for their prefabrication, processes. So this process, this research kind of helped us understand the step-by-step procedure of using the robotic total station. And then, as you know, we confirmed that robotic total station can expedite the process of laying out the location for the drywall. And then also it speed up the process of collecting as-built point data and creating as-built building information model. So the conclusion, if the as-built building information model can be created in real time as project is moving on, then it might be reasonable to expect that as-built building information model would facilitate project managers to identify potential problems and make proactive decisions to prevent schedule delays. So this is the message I'd like to provide you this morning, and thank you for your attention.